So session 1, virtualization and cloud technology. So basically what is the agenda of the session is this agenda is divided into two parts. Part 1 is cloud. Why cloud and advantages of cloud computing. So in this part we have cloud computing basics. How does cloud computing work? Definitions, essential characteristics and features of cloud, advantages of cloud computing, and cloud computing deployment models. Second part of this session is virtualization versus cloud technology, virtualization definitions, virtualization advantages, type of virtualization, full versus para virtualization, type 1 versus type 2 virtualizations, and hypervisor. I'm not muting all the participants in general, so anybody can ask questions in between, and I'm not forcing that mute all participants feature. So you can ask me during the training, and you can pause me and you can ask me questions. Definitely. But if you avoid during that session, that will be great. But even during this part also, I will be asking questions. If you have any questions, we'll be taking a review after every 5-10 slides or 5-10 points. Why cloud? A cloud service platform provide rapid access to flexible and low cost IT resources. I remember good old days when we used to have physical system hardware, and we used to spend huge money way back in 1990-91 when I purchased my 286 PC 286. That cost me around 32,000 Indian rupees, very costly at that time. So if I have to start a data center, look at the infrastructure I have to purchase, I have to set up, and then after making huge investment I have to wait for my customers. So a lot of investment is to be made in advance before we actually get our first customer and returns on the investment. So cloud has enabled you to not to make these large investments. So no need to make large investments in hardware and its management right in the beginning when you don't have any client, when you are just a planning phase, and maybe your planning may go wrong and this entire cost may go waste. So it actually cloud helps you that you pay as you go. You start with minimum, as you need you scale horizontally or vertically. So cloud gives you scalability. Provision exactly the right type and size of computing resources in the beginning as you need. For example, I'm hosting a website. Initially 2 GB RAM is good enough for me. But when my requirement increases, when my traffic increases, I increase my hard disk size from 80 GB to 120 GB, my RAM size from 2 GB to 4 GB, 4 GB to 8 GB, 8 GB to 16 GB. So as and when required, I can scale it. So provision exactly the right type and size of computing resources you may need to power your newest bright idea or operate your IT department. So you can access resources as you need and pay only for what you use. That is the definition of cloud. That's the advantage of cloud, why we need cloud. These are the reasons why you should have cloud. What is cloud computing? It's a multi-tenant solution provided by vendor. Multiple tenant here refer to the customer. Multiple customer solution provided by vendor. It is automated backups, uptime, service level agreements, maintenance, everything is applicable. That is cloud. Automated upgrades are there in cloud. Easy, elastic, pay as you go, scale up or scale down. Modern web-based integration, you can access it from browser. Web and mobile access from anywhere. So access from anywhere. Look at this, you are carrying your infrastructure in your pocket. That is what is cloud. So you go anywhere and you provision it, scale up, scale down. You do whatever you want in your pocket, in your mobile, in your tab. So that is what is the cloud computing. By definition, this is the proper definition of. I remember a movie, Three Idiots, and the definition of book given by Rancho. That was a complete technical definition of book. So cloud computing describes a new supplement, consumption and delivery model for IT services based on internet, and it typically involves the provision of dynamically scalable and often virtualized resources as a service over the internet. I don't know whether you are able to remember this or not, but put simply, it is something somewhere out there and we use it when we need it. I think this is the simple words. So definition given at the bottom is a summary of technically what is written in the first part. So concept is vast computing resource. The concept is simply that vast computing resources will reside somewhere out there, and will connect to them and use them as needed. But this is from the user's perspective. User perspective is this. From the administrative perspective, because I've been configuring cloud, I've been installing cloud, I've been setting up cloud on my system, on my in my office, creating the data center, everything. It is there's nothing called somewhere something out there. If we configure cloud, we have to have the scalable space, scalable CPU concept. We have, so what is below that level? From the customer level, that is customer level is the definition given here, but from our level we need to understand there has to be something physically there. Yes, true, but how this pool is created, from where the customers are taking their share. So the pool is created by the administrator, and virtualization helps you creating that pool. So virtualization often is used for the implementation of cloud, like virtual machine. Definitely there's a virtualization, boot disk or boot volumes, or the block volumes, or the object storage, or for that matter any type of storage, file storage. Everything is in the form of a virtualized environment. There's another layer created on the top of existing things, and then we use that in the cloud. So cloud is, for me, it is just another layer created on the top of existing virtualized resources, and a pool is created out of them. So cloud computing characteristics: on-demand self-service, ubiquitous network access, location-independent resource pooling, rapid elasticity, and pay per use. And that is the definition. Alright. Cloud computing is not. Sometimes there's a misconception about this. Alright. So for example, cloud computing is not network computing. Application and data are not confined to any specific company's server. There is no VPN access. Encompasses multiple companies, multiple servers, multiple networks. It is not that. It is not traditional outsourcing of your jobs. It is not a contract to host data by third-party hosting business. So no subcontracting for computing services for specific outside firm. It is definitely all these are strict no for cloud. What are the deployment models of cloud? We have private cloud, which we host for ourselves. We have public cloud, publicly available, like DigitalOcean is public cloud. Same way AWS is public cloud. Oracle infrastructure, OCI, Oracle Cloud Infrastructure is public cloud. So we have private cloud, we have public cloud, we have hybrid cloud, which is a mix of the two. Some part is government, some part is private. So I mean public and private. So it is mix of the two. That is hybrid. And then we have third option is community cloud. We have a community cloud model. So there are four different deployment models of cloud. Let's understand one by one. Private cloud. These services are managed and provided within the organization. For example, HP data center. That is private cloud only for HP. It gives organization greater control over security and data, which is safeguarded by firewall and managed internally. It can be hosted internally or externally. That is private cloud by definition. Public cloud. Services are delivered over a network for public use. Customers do not have any control over the location of the infrastructure. It is a service provider, and the cloud service provider create the data center, manage the data centers, availability domains, availability zones. So cost is shared by all users and are either free or in the form of license policy key or like a pay per user. Public clouds are great for organizations that require managing the host applications and the various application users use. For example, Amazon Web Services, DigitalOcean, your own OCI, all these are examples of public cloud. Hybrid cloud, it is a combination of services provided from public and private cloud. Resources are managed and can be provided either internally or by external providers. A hybrid cloud is great for scalability, flexibility, and security. For example, ERP in private cloud. Scale and sales and email for public. They are hybrid cloud examples. So this is hybrid cloud example. Then we have the community cloud. Community cloud is an infrastructure that is mutually shared between organizations that belong to a particular community. The community members generally share similar privacy, performance, and security concerns. An example of this community cloud is at banks, government in a country. So what is our community cloud? NIC in Government of India. They have their own cloud. Or trading firms. Community cloud can be managed and hosted internally or by third-party provider. And I've been working with the NIC cloud also, which is Government of India cloud. Major cloud servicing computing services. Up to here, I would like to open the session for questions. Please feel free to ask questions at this point. Anybody? Yes, team. Open your mic. Yes. Yes, that is what. Good question. Let me take more questions. Please, anybody, any other question? I would like to take the questions. Mm-hmm, 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 mm-hmm. Absolutely. Yes. Mm-hmm, mm-hmm, mm-hmm. Okay, let me explain. First of all, the definition of private and public. Um, Let me share with example rather than this. Okay, oh, 1 second. Let me stop sharing. I'm sharing my entire desktop. Now, if you see here, I have my own Oracle, virtual machine, Oracle VM virtual box. Let me open this. It takes time. Just yeah. Here you see controller, compute, and storage. These are the three machines which I have created. This is actually a cloud. Now, if internally I have some IP address pool and my company is big enough which require cloud services, so that will be a private cloud. As I said, HP data center. HP has its own data center internally for the organization, and they are not sharing it. They are not letting it out. They are not. That's not public. They are not, allowing third-party companies or any other vendors or any other clients to join. So that is for internal. So for me, that is a private cloud. So if I configure cloud here for myself, that is private cloud. So private means within the organization, not crossing the boundary of the organization. Public cloud which you set up for the public, where you create environment, you create physical environment and infrastructure, and then you are letting it out to the public and let the public access it and pay for what they use. So you make huge investment to make the public cloud, like Amazon has been investing. And it's not you are investing in, Amazon is investing on the public cloud, and then they are asking the users to join. They give some initial credit also, like, or OCI is giving 400 SGD credit for the trial account. So they made investment for setting up the data center, for setting up the things, and then asking the public to join, public to use it. That's a public cloud. So where the public at large is allowed. NIC, for example, you cannot join as a public, you cannot participate as, and NIC is a very good example of a hybrid cloud. Some part of it is public, some part is private. So NIC cloud is a very good example of hybrid cloud. OCI, I'll not call it as hybrid. OCI, I will call it as a public cloud, because anybody can join. NIC, not everybody can join. All right. Mm-hmm. Mm-hmm. Now anybody can access, and I mean I cannot, for example, I cannot have my own hardware to be a part of OCI, right? So similarly, definition of one was that whether physical it is hosted. Yes, physically we require a cloud administrator. For example, I'm cloud administrator. I know how actually the storage of OCI is working. Object storage is working. It is using backend is Swift. Object storage is being used by Oracle Cloud. I know which OpenStack, like for example OpenStack Cloud. I can deploy OpenStack Cloud, give me physical machines, and I create and configure it, and I deploy Oracle Cloud, and I make a cloud for you. So physically you have to have the hardware. You can deploy configure. Please. Yes. 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 True. Very right. True. 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 Okay. Now we have major cloud computing services. We have SaaS, PaaS, and IaaS. In fact, we have more, like database as a service. Whatever can be offered as a service is actually a service of cloud. For example, if I offer software as a service, all right, SaaS. Example is Google Apps or Salesforce. So that software is offered as a service. You can subscribe to the software and you pay for what you are using. So applications typically available via browser are software as a service, like Google Apps and Salesforce.com. We have platform as a service. Platform is basically you hosted applications environment for building and deploying cloud applications, like Amazon E2C, Elastic Compute Cloud, Microsoft Azure. These are platform as a service. But when we say infrastructure as a service, it is utility computing data center providing on-demand servers, the server resources, like HP Adaptive Infrastructure or Rackspace or S3. Even IaaS is offered by OCI. Even Amazon offer IaaC, infrastructure as a service. So infrastructure as a service is offered by Amazon, is offered by Oracle Cloud, is offered by DigitalOcean also. So it depends what is offered. It is actually what level of cloud is available to you for the purpose of uses. So SaaS, PaaS, and IaaS are the two things. Yes, Sunil, tell me. Sunil. Yes. Mhm. I'll tell you. I'll tell you. When I say platform as a service, I will provision a machine for you. I will set up the software for you, and I'll give you access to that software, to that virtual machine. So provisioning is done by me. Setup is done by me. The right kind of hardware, right kind of software is done by me. Ready machine is created for you, and I'm giving you access right for use of that machine. So I'm giving you platform. Yes, which you expect. Basically, you know what, when you say that's a very good question. Actually, to draw the line, we need to draw the boundary. Let me draw the boundary between these three different layers. IaaS gives you complete control, so no boundary. You get access to everything, so you deploy everything for yourself, right? So infrastructure as a service is complete control. Ratnesh, you can please mute your mic, because it creates disturbance sometime. Whenever you have to speak, unmute it, please. So infrastructure as a service is basically when you are getting complete control of setting up the infrastructure for you. This is one. So you require a greater knowledge, greater depth, greater level of technical skills, and technical manpower is required for this purpose. As a client, you need technical people to set up the cloud for you, because you are getting infrastructure. So if you don't have that technical skills and technical ability, what probably second level is platform. So for example, you have to host a website. So obviously you need Apache server pre-configured, installed, MySQL database pre-installed. So you need a platform to host your website. So the platform as a service means you will require lesser level of skills, lesser level of technical people for deploying platform as a service, because infrastructure is already set up for you. So the company providing the cloud services is setting up the environment for you, and they are giving you ready platform to host your softwares, right? That is platform as a service. But if you don't want any technical knowledge, you just want to put your stuff, the platform was also created for you, and you just want to put your applications or your data. For example, Google Docs. So Google Doc is not platform as a service for me. Google Doc is software as a service for me, right? So Google Doc, where I can put anything on myself. Google Drive is a software as a service for me. So software as a service, where infrastructure is set up by the cloud service provider, platform is set up by the service provider, software is installed by the service provider, and you're just using it. So that draw the line between the two. So level of control and level of accessibility. What you get, what you have access to, what layer you are allowed to access. The minimum layer, minimum access is on software as a service. Little more platform access, and more the maximum is infrastructure as a service. Got the point now? True, true. Yes, yes. Software, whatever installed platform is ready for you. Yeah, right? Yeah. Another question? Keep this interactive. If everybody keep this interactive, nobody will be able to get a chance to sleep, because generally in training people sleeps. Yeah. You know what? Let me continue the session. I will tell you, because during this training you will be seeing the boundary in a more clear form. If there is some gray area, that will be cleared once I demonstrate you. Look, Oracle offers this as infrastructure as a service, and this is platform as a service. That will draw the boundary in a finer way. Uh, we are right now just understanding the concepts. Okay, that will help you. I'm sure that will help you. Okay. Yeah. Yes, Suresh, tell me. Hmm. No, when we say Google Apps, I'm talking about Google Play Store. So Play Store is what you're doing. You are just using software as a service. You dump your apps there, right? So I give more example like now, for example, yeah. For example, Google Docs, Google Drive, Google Apps, Google Play Store. All these are software as a service, right? Yeah. Yes, I can give. I want to host, let's say, a website. So, what is the platform required for a website? You know that typically we require web server, we require database server, we require operating system. So, I ask my service provider, please set up the environment for me so that I can host my website. So, platform basically include the operating system and the required software to run your application. Y- Yes, yes. Absolutely, absolutely, absolutely. Anybody free to add? Yeah, free to add knowledge. Please share your knowledge if you have. That will make things more clear. Yeah. Thank you so much for sharing your information. Yep. Okay. So the second part is virtualization. Virtualization. This will clear many doubts because I have seen in the previous batch also. There are some gray areas. Participants are not clear, very clear about the concept of virtualization. However, if you know, so wait for any one sentence or any one point which will add knowledge to your, enhance your knowledge for that. So just look for that one point information which you may get during this discussion. So second part is virtualization versus cloud. Virtualization definition, virtualization advantages, type of virtualization, full versus para virtualization, type 1 versus type 2 virtualization, and hypervisor. Virtualization and cloud computing. Virtualization is ability to run virtual machines on the top of a hypervisor. Hypervisor is also called virtual machine manager. So if we have so many things to discuss here because before I actually continue on the slides, I need to give examples that will help you in understanding. You know, we can have direct bare metal hypervisor where the hypervisor is installed on the top of the physical machine. Of course, minimum operating system is required, and that minimum operating system is part of the hypervisor itself. So, for example, Red Hat has its own hypervisor, Red Hat Enterprise Virtual Machine Manager, RHEVM. So we have a hypervisor which is directly installed on the hardware, that is called bare metal. We may have an operating system on the top of which we install hypervisor and we configure machines. So we have a dedicated operating system. We have operating system doing its own job, other jobs also, means other applications are also running. But hypervisor is running as a separate, as an independent software, and which is used to manage the uh, guest machines or the virtual machines. Like in my case, if you notice that I have Oracle VM virtual machine running, and which is in addition to my other applications. My other applications are also running. So that is another type of hypervisor. And there is another layer called para virtualization, where some part is virtualized to optimize the application. And there is something called another way called emulator, like Wine. Uh, Wine is not an emulator, so that is a recursive full form, wherein one independent application of different platform is running in an emulated environment in your operating system. For example, if I want to run Internet Explorer on Linux, I can do that. So I require Wine for that purpose. and I can run Internet Explorer on Linux also using that concept. So virtualization is ability to run virtual machines, not typically virtual machines, maybe virtualized emulators or different concepts. So on the top of hypervisor. Hypervisor, as I named, it is a virtual machine manager or the software which gives you environment to create virtual machines. So hypervisor provides a uniform abstraction of the underlying physical machine. Abstraction is the key idea in service model of cloud, because it is cloud is based on virtualization. Cloud cannot survive without virtualization, and hypervisor gives you that abstraction layer. Hypervisor gives you that technology to create cloud. So virtualization can make one resource act like many, while cloud computing lets you different departments, though through private cloud, or companies through public cloud, access a single pool of automatically provisioned resources. Remember, automatically provisioned. This is what the layer which I was talking about. I was talking about virtualization is running somewhere we have physical things. Somewhere we have virtualized them, creating a pool of it, and on the top of that we set up the cloud. So this is the automatic provisioning is done by that layer which I was referring to, which I was trying to explain at that time. You will get more clear difference between the two. Look at the boundaries. Definition of virtualization: it is a technology, whereas cloud is methodology. I'll not call it as a technology because it's using the technology of virtualization to set up the cloud. So cloud is methodology, virtualization is technology. Purpose of virtualization is create multiple simulated environments from one physical hardware system, whereas cloud is pool and automate virtual resources for on-demand use. Use of virtualization: deliver packaged resources to specific users for a specific purpose. Cloud delivers variable resources to group of users for a variety of purposes. Virtualization configuration is image based and cloud configuration is template based. We create templates and we use them. Lifespan for virtualization is years, it is long term, and cloud there is no set lifespan. It may be hours, it may be months, it may be years. That depends for how long you want to use it. Cost is definitely for virtualization high capital expenditure and low operating expenses. For cloud is for private it is high capital expenditures, and public cloud it is low capital expenditures. Same way for private cloud is low operating expenditures, and for public it is high operating expenditures. Virtualization scale up, cloud scale out. Workload stateful in virtualization, in cloud it is stateless. That is the difference between virtualization and cloud. I was talking about the definition. This is what I already discussed. Yes, tell me any questions so far? Yes, Suresh. Hmm. Yeah, please. Yes. Yes. Yeah. Sure. See, when you see for virtualization, you create a ready virtual environment for uh, a set of predefined virtual components. So that's why I called packaged resources, right? For a specific purpose. So package means I have a ready package which I will deliver to you. So it is already predefined, right? Whereas in cloud it's variable resources. You don't package anything, you don't make any group anything, because we are using a pool and we are scaling out which is template based. So you can add resources. There's nothing called fixed size of resources. Even if for example you're talking about two virtual machines, you want to scale out as automatically also, that can be done. So there's nothing called package, there's nothing called predefined, there's nothing called a list of pre-existing resources which is delivered and charge fixed. No, we can change anytime. Anytime means you configured with something and you see that speed is you are compromising on the speed, and you want to next 1 hour you want to improve the speed and you want to increase the resources. So nothing is packaged here, nothing is fixed here. So it is variable resources, and different set of resources are grouped together, not one. Like you want a setup, complete setup, or let's say virtual network also, right? You want a database also, you want a virtual machine also, operating system also. Obviously. Yeah, yeah. Yes, 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 yes. So there's no fixed list of resources. You can add the list of resources as you need. No, 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 no. Because as you are paying as you are going. Good question. Yes. Yeah, horizontal and vertical scalability. Scale up is horizontal, vertical scalability. Vertical scalability refer to adding features. Scale out is growing horizontally. Horizontally means load balancing or performance. Where let me take example, very simple example of a window. We have one inquiry window open, and we have a queue in front of the window. Now the queue size may increase or decrease, and it may be so heavy that one person is not able to handle the entire queue. So if we have only one window, we cannot scale it out. We cannot handle the load. What we need to do is we need to open another window. We probably have to depute second person. If the window is 24 by 7, then we may have to depute three more employees with a maximum duration of 8 hours. So 8 into 3, we require 3 manpowers. So if we are running two windows, so we are scaling out here to handle the load, to handle the traffic. That is scale out. When we adding the features to the existing thing, that is virtualization. Yeah, yeah, yeah. Verticals. I use two different words in fact here. One is scaling up, one is scaling out, or vertical scalability and horizontal scalability. Vertical scalability basically refer to the foundation and then growing, how far you can go. So structured growth is possible in virtualization. And horizontal scalability basically refers to availability, refer to performance, refer to load balancing, refer to disaster recovery. So cloud gives you disaster recovery, cloud gives you availability, cloud gives you load management, load balancing, cloud gives you performance. Yeah, stateful is where you require user ID password, where you are creating a session. Once the session is created, you are only able to log in that for that duration of time. So stateful is you have to remain connected. For example, right now the session which is going on is a stateful session. The moment I log out, you are no more accessible to me. This is called stateful. Stateless is which is available 24 by 7. You don't have to log in to access it. It is available. Like when I host a website, it has to be stateless. So there is no session created. There is no handshaking. When you configure it, you provision it, make it available. It is available now. Like website is stateless. Absolutely, yes, yes, true. Yes. Yeah, no, that is correct. That is correct. That is correct. Whatever is available, where you don't have to log in. Stateless state itself is what? Session. Session. Do we require a session for virtual machine? Yes. For cloud, no. Once you provision that, it is available to you, right? So handshaking and availability. Oh, okay. More technically, I will say where a thread is created with the operating system and there's a process on the operating system handling your connection. That is stateful. When there is no process handling your connection and handling you, that is called cloud, right? So operating system does not start any process for you to handle your connection. That is cloud. For operating system, for virtual things, you require. For virtualization, you require. Yeah. Welcome. Yep. 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 Yes. Yes, Sunil. We can do scale up and scale out both, because virtualization is definitely is a part of cloud. So broader perspective, yeah, broader perspective, comparatively, we are trying to understand the difference. So broader perspective, we can do a scale out in cloud. True. It is sometimes what the perspective is become more important than the what is written. In what perspective it is written, right? Yeah. Welcome. Virtualization definition: multiple operating systems on a single machine is the definition, giving illusion that each operating system is running on real hardware. Virtual machine monitor, VMM, or virtual machine manager, or hypervisor, this is one and the same thing. This is another layer of kernel to virtualize multiple operating systems, also called hypervisor. An operating system as a supervisor is no more hardware dictator, because when you create a virtual machine, you have your own control on the hardware. So for example, we have at the bottom we have hardware, we have virtual machine manager, and then we are running three different operating system: Mac, Linux, and Windows. We are running three different operating system on one hardware. That is definition of virtualization. Virtualization advantages: efficient resource utilization, low resource utilization for each server machine, total low total cost of ownership, that is TCO, and low cost of infrastructure and energy. That is advantage of virtualization. I'll tell you, in my case, I have 16 gig of RAM on my machine. Out of 16 gig, trust me, I have 4 machines. If you saw that, my Oracle VirtualBox, each one of is having like 3 of them is having 6 gig of virtual machine each, 6 gig of RAM each, and 2 of them have 2 gig each. So practically, I mean theoretically, I have given 6 plus 6 plus 4. So I have given entire 16 gig, but that does not mean that I cannot start my operating system and I cannot start all my 4 machines. I can do that. Why? Because there is a concept of overcommit. Virtualization gives you the concept of overcommit, that assuming that no operating system, no machine will be utilizing the RAM to its full capacity. So that means one of them may be using only 1 gig of RAM, another might be using out of 6 gig assigned only using 4 gig of RAM. So effectively you can actually give the resources as per your requirement. That makes sense, right? So we have a low resource utilization. That is the actually idea. That was the idea behind creating the concept of virtualization, because the CPU, the disk, everything was always underutilized. Just imagine the scenario: I have to demonstrate the cloud configuration to for my training. Do I need to carry 4 laptops? Doesn't make sense. My one laptop with 16 gig of RAM is more than sufficient to demonstrate the concept. So that give me freedom. So that is the best advantage. So efficient utilization of resources is the best part of it. Same way, we have flexible virtual machine relocation. Ultimately, virtual machines are hosted on a physical environment. That is true. But virtualization has a concept of live migration, and I have done that in Zen virtualization. SUSE was hosted. We created an environment. We migrated virtual machine from one host to another host. So, so we have flexible virtual machine relocation. Live VM migration is possible. So flexible VM relocation with near zero downtime is possible. Flexible load balancing, relieving resource bottlenecks. Definitely, bottlenecks are no more there. And strong isolation. Look at the second part of the figure here. We have one hardware operating system and the app. So this virtual machine has some problem here. But if this will create problem. and for the other application also, because it's creating problem for the operating system. So this is not the good example. What we have in virtual machine concept is we have virtual machine manager, we have one operating system here, and this machine is safe. There is no problem with that. This machine with this operating system has a problem, no problem. This is completely isolated. So this effect, the second virtual machine which is infected by some virus or some problem, has some snag in it, will not affect the other virtual machine running on other operating system on the same virtual machine manager or same hypervisor. So that isolation is ensures the safety and security of the guest machines or applications running on the second hypervisor. So strong isolation between co-located virtual machines, fault containment or isolation, safe from bugs and malicious attacks. That gives you the power of advantage. That gives the advantage of virtualization. Type 1 versus type 2 virtualization, depending on what sits right on the hardware. For example, the first part, type 1, on the top of hardware what you have is hypervisor or the virtual machine monitor. So on the top of the hardware you install hypervisor, and then on the top of the hypervisor you install guest machines. Now obviously don't ask me that we require operating system on the hardware first. I have already answered this question, because the virtual machine manager for this purpose is having the bare minimum operating system required. That means the kernel is a part of hypervisor. So minimum operating system required for that is a part of the hypervisor itself. So examples are VMware ESX, Hyper-V from Microsoft, Oracle OVM, then we have IBM Power VM, and Linux is KVM. These are type 1 hypervisors. So we can have this directly installed on the hardware, and we can run guest machine on this. Type 2, we have host operating system on the hardware. So we have hardware on the top of which we have operating system like Windows, and then we install virtual machine manager on it. For example, in my case, Oracle VirtualBox. The VM VirtualBox which I demonstrated was part of type 2. Same way VMware Workstation is type 2. So if we have operating system running independently, applications running on that operating system independently, and then we install hypervisor on the top of that operating system, and then we create guest machines on that, that is type 2 hypervisor or type 2 virtual machine manager. So type 1, type 2, these are the two virtualizations concepts. CPU virtualization, now general very basic definition for the people who don't know anything about virtualization, who don't have any background. These are some basic definitions for them. CPU virtualization, what is it? It involves a single CPU acting as if it were multiple separate CPUs. The most common reason for doing this is to run multiple different operating systems on one machine. And the underlying physical resources are used whenever possible, and virtualization layer runs instructions only as needed to make virtual machines operate as if they were running directly on the physical machine. So we have a CPU is virtualized for this purpose. Then second, we have storage virtualization. Like I remember I configured LVM on my disk, on my storage server. You see my cloud on my Oracle VirtualBox. So I installed LVM, I configured LVM, I created partitions, I added multiple disks, and I created LVM on the top of that. So I can virtualize it now, and I can use it for my cloud. So from storage server, virtual disks are created to be provisioned to virtual machines. The actual physical storage devices are used to carve out virtual disk. A VM can use one or more virtual disks, and this is what we have done. That's what I also have done. I'll show you machine creation, virtual machine creation, and I will demonstrate this virtualization concept. I will show you very briefly how to install, and that will be great for you if you do it yourself also. I will demonstrate this right after this session quickly. Network virtualization. Typically, networks are made up of physical cables and network interface cards, routers, and switches. That is definitely we have the physical. Same can be virtualized. Means the physical network interface cards, physical routers, physical switches can be virtualized, and we can have virtual networks or virtual network interface cards, virtual routers, virtual gateways. So same can be virtualized using software on the top of physical components to provide virtual environment to virtual network interface cards and routers and gateways. So that is network virtualization. And that's all for this session.